Hello everyone, I am Navin Kumar and my roll number is 21955A2106 and I am from Aeronautical Engineering Section A from IARE College. And I have my TED talk on in max subject and the topic is regarding one factor analysis of variance for medical statistical data with binomial distribution. And coming to here you can see this slide statistics in medicine. Oh, you will think that there is no use of maths. Some of you not all. There is no use of maths, but it plays a major role in our daily life. If you see, it will be used to find out whether sure it will be conducted in BP test and how many patients and how much they have in the range like that, and height and weight in condition of height and weight testing, and how many are recovery and how many are not recovered. In that cases also they will do. And coming to beds in hospital, how many beds have and how many patients, the relationship between them it will gives. And coming to patients and how many of them injured and how many health issues regarding that it will gives. And coming to surgeries, how many doctors have and how many patients have they have to do the surgery. So it will plays a major and vital role in our lives and daily lives. And coming to this method, this is the new method of one factor analysis of variance for a medical statistical data with binomial distribution is studied in this paper. The total probability variation of the control groups in decomposition into samples and probability probability variation between samples in a control groups. The statistical analysis will be done to the data with binomial distribution by using one factor analysis method. The result by this method is correct. The conclusion by this method is reliable. Yes, and this slides will be tells about that using one factor variance formula in the binomial distribution. So yeah, whether it is valid or not valid. About that, that is my topic. And if you see some of the formulas in binomial notation of a binomial distribution mass formula, and this is for your revision, not English for our topic. If you see this, P of x is n into Cx or P power x and Q power n minus. The P is the probability of success, Q is the 1 minus Q, we can find 1 minus P is a probability of failure, and n is the number of trials or experiments. X is the number, X is the success values, and coming to S is add notice the n of Cx, and it can be solved in terms of n factorial by x factorial by n minus x. And you see this blood pressure relation. How this is the BP and this is the test score, and these dots will indicate the stress, and this is by this variance, by using variance we can find out how the BP will be varied. And if you see some of these examples in our daily life, if you should see this, and if you consider this one way analysis for the pharmaceutical in medicines in controls, what are the drugs, and if we use we have different types of drugs in market, like they have one company have one drug and other company have drug. If we use that drug, which company will give you more more good results, then we will prefer that. So by using this method we can verify or find out which is the good drug for us, and this will graph will show that only control and drug A and drug B and drug C. If you see this example, drug B have more, what I say, more good results. So I have taken this picture for that purpose, show for your understanding purpose. And this something paras test, and this is the general formulas which is used in the binomial distribution. If mean is equals to mu is equals to np, here the p is equals to probability of success, n is equals to number of trials, and mu indicates that mu is equals to mean. And the variance, it is indicated with sigma square. A variance is equals to npq, and n is the number of trials, and p is the probability of success, and q is the probability of failure, what you can say. And the q value we will find out that p plus q is equals to 1, and so what I say, p is equals to 2 minus 1, like that we can find out. This is the standard. It means it indicates that standard deviation, and it is indicated with sigma. Sigma is equals to the root of npq. The root of variance is called, uh, what is it? If you see this both, if we add a root and the square will be get cancelled. So like that the standard deviation formula we have. And coming to here the variance formula derivation, how it will be getted, how it will come. Here the variance formula is npq, and from this relation we can say n into n minus 1 p square sigma of pi in x. To take x is equals to n of n minus 2 factorial by x minus 2 factorial into n minus x factorial p x minus 2 and q power n minus x plus np. So and we get that n into n minus 1 p square sigma and c power x, what I say, for this n minus 2 by x minus 2, this we can written as n power c power x formula. So n minus 2 by c power x minus 2, and it is same. And coming to here, we have same. Here we in the same place of sigma we have written that p plus q and np, and it is same like derived. And here the variance, we have formula of variance, e power of x, e of x square minus e of x into whole square, it is equals to n of n minus 1 p square plus np minus np square np whole square. And from this we can write written as np minus np square. Here the mu is the np and np square, yeah, np square. Np is equals to 1 minus np. From that, from this we can understand the npq, how it will be getted. And this is the formula for the variance to find out various results. You can see this is the height distribution by using normal distribution, not by binomial. For understanding purpose, I have taken this normal distribution. This curve will indicate how many members and what are the heights, and different people have different heights. So I have taken this. And finally, concluding my topic, thank you for listening. And one more thing I want to tell, that um, yeah, maths in the mathematics, it is this is a mathematics which will play a major role to find out the various problem solutions in, in medical and other, as well as other fields also. If you see, uh, thank you for